Bearing. Contents. Introduction, classification, terminology, function of bearing, selection of bearing types and application, bearing specification, classes of fit, mounting of bearing, dismounting of bearing. Introduction. A bearing is a device to permit constrained relative motion between two parts, typically rotation or linear movement. When there is a relative motion between two machine parts, one of which supports the others. The supporting member is called bearing. Classification of bearing. Bearing are classified depending upon the load. Bearing are also classified depending upon the type of contact. 1. Sliding contact bearing. Journal bearing. Plain bearing. 2. Anti-friction bearing. Ball bearing. Roller bearing. Terminology: inner race, outer race, inner and outer diameters. Width. Function of bearing. A bearing permits relative motion between two machine members while minimizing frictional resistance. A bearing consists of an inner and outer member separated either by a thin film of lubricant or a rolling element. A bearing bears the load. It locates the moving part's in correct position. It provides free motion to the moving part by reducing friction. Selection of bearing type. Each bearing type displays characteristic properties, based on its design, which makes it more or less appropriate for a given application. The most important factors to be considered when selecting a standard bearing type and thus facilitate an appropriate choice. Available space. Loads. Misalignment. Precision. Speed. Quiet running. Stiffness. Axial displacement. Mounting and dismounting. Integral seals. Loads. Magnitude of load. The magnitude of the load is one of the factors that usually determines the size of the bearing to be used. Generally, roller bearings are available to support heavier loads than similar-sized ball bearing, and bearings having a full complement of rolling elements can accommodate heavier loads than the corresponding caged bearing. Direction of load. Radial load. The load which comes perpendicular on the shaft called radial load. Cylindrical roller bearing, needle roller bearing, and toroidal roller bearing can only support pure radial loads. Direction of load. Axial load. The load which comes axis on the shaft called axial load. Thrust ball bearing and 4-point contact ball bearing are suitable for light or moderate loads that are purely axial. Direction of load. Combined load. A combined load comprises a radial and an axial load acting simultaneously. For combined loads, single and double row angular contact ball bearing and single row taper roller bearing are most commonly used, although deep groove ball bearing and spherical roller bearing are suitable. Speed. The permissible operating temperature limits the speed at which rolling bearings can be operated. Bearing types with low friction and correspondingly low heat generation inside the bearing are therefore the most suitable for high-speed operation. Types of bearing: thrust bearing, ball bearing. Single row deep groove ball bearing. Double row deep groove ball bearing. Angular contact ball bearing. Single row angular contact bearing. Double row angular contact bearing. Roller bearing. Cylindrical roller bearing. Tapered roller bearing. Spherical roller bearing. Needle roller bearing. Thrust bearing. Single row thrust bearing, ball and roller. Double row thrust bearing, ball and roller. Journal bearing. Solid journal bearing. Split journal bearing. Ring oil journal bearing. Plain bearing. Ball bearing. Point contact, support radial and axial loads. A ball bearing is a common type of rolling element bearing. Point contact, support radial and axial loads. Angular contact ball bearing. Designed for axial loading, used in pairs. These bearings are used where the thrust load is equal to or greater than radial load. Thrust ball bearing, designed for pure axial loading. This type comprises a row of balls running between two flat groove washers with balls tracked designed to absorb thrust load in one direction. This does not withstand any radial loads. Also with this is not suitable for higher speeds. Roller bearing. Roller bearings are used in rotary applications to replace sliding movement with low friction, rolling motion. The principal types of roller bearings are cylindrical, spherical, and tapered. In general, roller bearings offer higher load capacities than ball bearings of the same size. Cylindrical roller bearing supports high radial loads, slower speed ratings. Tapered roller bearing. High radial and axial load ratings, used in pairs. These bearings carry heavy loads at moderate speed. They should always be mounted in pairs with opposed taper because in each bearing the radial load produced an axial component which needs counterbalance. Spherical roller bearing allows for misalignment. These bearings are suitable for use with independent support housing and wherever there is possibility of a lack of alignment. It can carry medium or heavy radial or combined load. Needle roller bearing thrust and radial types, typically no inner race. These bearings are used in plans where the speed and low or oscillation takes place as in wrist pin, rocker arm, universal joint etc. Journal bearing. A journal bearing is a simple bearing in which a shaft, or journal, rotates in the bearing with a layer of oil or grease separating the two parts through fluid dynamic effects, solid journal bearing. The solid journal bearing is made of bronze. The bearing is bonded to a steel housing. A bushing is a relatively thin journal bearing that receives most of its strength from the hooping in which it is mounted. This bushing has a lubricant groove. Split journal bearing. This bearing is split into two parts. This bearing is bounded to its housing. The split design of this bearing and housing has an advantage while the bearing needs to be repaired because it is easier to remove both the bearing and the housing from the shaft so that they can be examined. This housing has a grease note at the top in which a fitting is inserted when the bearing needs to be lubricated. Plain bearing. It is also comes under category of journal bearing. Plain bearings and sleeve bearings, journal bearings, are used to constrain, guide or reduce friction in rotary or linear applications. Bearing specification. Each anti-friction standard bearings has a specific basic designation which indicates the type of bearing and other construction features. 302. Code for width series. Code for rod. Code for type. Bearing specification. Each anti-friction standard bearings has a specific basic designation which indicates the dimension of bearing. X 2020. Code for bore diameter. Code for dimension series. Code for bearing type. Code for bearing. 0 double row angular contact ball bearing, 1 self-aligning ball bearing, 2 spherical roller bearing, spherical roller thrust bearing, 3 taper roller bearing, 4 double row deep groove ball bearing, 5 thrust ball bearing, 6 single row deep groove ball bearing, 7 single row angular contact ball, 8 cylindrical roller thrust bearing, C carb toroidal roller bearing and cylindrical roller bearing, QJ 4-point contact ball bearing, T taper roller bearings according to ISO 355 1997. Classes of fit. 1. Loose clearance where accuracy is not essential, such as in road building and mining equipment. 2. Free clearance in rotating journals with speeds of 600 revolutions per minute or greater, such as in engines and some automotive parts. 3. Medium clearance in rotating journals with speeds under 600 revolutions per minute, such as in accurate machine tools and precise automotive parts. 4. Snug clearance where small clearance is permissible and where moving parts are not intended to move freely under load. Classes of fit. 5. Ringing interference where light tapping with a hammer is necessary to assemble the parts. 6. Tight interference in semi-permanent assemblies suitable for drive of shrink fits on light sect irons. 7. medium interference where considerable pressure is needed to assemble, and for shrink fits of medium sections, suitable for press fits on generator and motor armatures and for car wheels. 8. Heavy force or shrink interference where considerable bonding between surfaces is required, such as locomotive wheels and heavy crankshaft discs of large engines. Preparation for mounting and demounting. Before mounting, all the necessary parts, tool, equipment and data need to be at hand. It is also recommended that any drawings or instruction be studied to determine the correct order in which to assemble the various components. Housing, shafts, seals and other components of the bearing arrangement need to be checked to see that they are clean, particularly any threaded holes, leads or grooves where remnants of previous machining operation might have collected. Mounting method. Depending on the bearing type and size, mechanical, thermal and hydraulic methods are used for mounting. 1. Cold mounting method. 2. Hot mounting method. Cold mounting. If the fit is not too tight, small bearings may be driven into position by applying light hammer blows to a sleeve placed against the bearing ring face. The blows should be evenly distributed around the ring to prevent the bearing from tilting or skewing. The use of the mounting dolly instead of a sleeve allows the mounting force to be applied centrally. Hot mounting. It is generally not possible to mount larger bearing in the cold state, as the force required to mount a bearing increases very considerably with increasing bearing size. The inner rings or the housings are therefore heated prior to mounting. Bearings should not be heated to more than 125 C as otherwise dimensional changes caused by alterations in the structure of the bearing material may occur. Bearing fitted with shields or seals should not be heated above 80 C because of their grease fill or seal material. Dismounting method. 1. Cold dismounting. 2. Hot dismounting. If the bearings are to be used again after removal, the force used to dismount them must never be applied through the rolling elements. With separable bearings, the ring with the rolling element and cage assembly can be removed independently of the other ring. To dismount a bearing having an interference fit, the tools described in the following section may be used. The choice of tools will depend on bearing type, size and fit. 1. Cold dismounting. 2. Hot dismounting. Cold dismounting. Small bearing may be removed from their settings by applying light hammer blows via a suitable drift to the ring face, or preferably by using a puller. The claws of the puller should be placed around the side face of the ring to be removed or an adjacent component. Hot dismounting. Special induction heaters have been developed to dismount the inner ring of cylindrical roller bearing having no flanges or only one flange. They heat the inner ring rapidly without heating the shaft to any degree, so that the expanded ring can easily be removed. Bearing lubrication. Lubrication reduces friction. It also prevents wear and corrosion, and guards against solid and liquid contamination. Theoretically, a properly lubricated bearing operating under ideal conditions will last forever. This is not possible in reality, of course, but a properly lubricated bearing has the best chance of achieving its maximum service life. Lubricant SUPLLY system. Oil and grease require different types of supply systems. Several oil and grease supply systems exist that meet the needs of various bearing applications. Oil supply systems include oil baths, circulating oil systems, spray or mist systems, and the wick feed method. Grease supply systems include housings, with or without grease fittings, grease chamber lubrication, and the grease quantity regulator.